hope that works for her. All right, so lesson 4 is Python functions. Functions are at the heart of Python programming. You want to turn everything into a function. And the big difference between a beginner programmer and an intermediate programmer is the ability to use functions as opposed to just doing everything line by line, scripting out your code. And I've actually been on a number of projects where I see people who are still doing that, even for massive files of like 300, 400 lines. They never use any functions. And to me, it's like somebody who learned how to type with 2 fingers. You ever met somebody who, when they were a kid, they just learned how to type with 2 fingers, and they never took the time to learn how to type with all 5 because they were like good enough? And so now they're like 45 years old and they're still using 2 fingers to type. That's what it's like if you get into Python programming and you never learn how to use functions. They're a little intimidating at first. It can be a little confusing. But once you learn how to do it, you just want to make everything a function because it is more efficient, it's more accurate, it's less prone to fat finger error, and above all, it allows you to reuse your code. The reusability of code is a tremendously powerful thing. And it's one of the things that separates, for me at least in my career, prior to using Python, I used 2 statistical programming packages, which were SPSS and Stata. Neither of them has the ability to easily create a function unless you build like a macro. And so I was constantly copying and pasting huge blocks of code and then going back through with Control F or Control R in order to replace certain variables in my for loops and my if-then statements in order to get it to run. None of that happens with Python because you write a function and then you just keep reusing it. That's what tonight's class and also next week's classes are about, is how to do that correctly and efficiently. So we're here in lessons. As usual, we have lessons and then also assessments. And then inside lessons, we have challenges and solutions. I've got the solutions over here on my left-hand laptop, which I'll be working from. And then I'll be filling out the lessons folders one by one. I'm going to see if I can get through all 4. I'll also try to remember to give a break. I know I forgot to do that last time. So try and make sure I get a 10-minute break in there at a certain point. Let's dive into Intro to Functions. And I invite you to code along with me. Okay, so we've gone over a lot of variable types, and we've used them to build statements, for loops, if, then statements, while loops. Control flow is a Python term for, again, reusing your code in chunks or building blocks. And that's where functions come into play. Functions are sort of the Lego blocks of Python programming. With functions, we'll be able to scale up immensely. We'll be able to start doing a lot more with a lot less code. So the basic parts of a code are the definition statement, which is always DEF, the inputs, which are also referred to as arguments, and the outputs, which can be fed back to the user either with the return or the print statement. Okay, so let me spell that out. Every function begins with the letters DEF, and then it has a name. You can give it any name you like. I choose to use myfunc for a lot of them. And then it takes in some inputs, often called arguments. Argument, and it can have multiple arguments. Argument 1 and argument 2. And then the definition statement ends with a colon. Just as we saw with for loops and if-then statements, whenever a Python line ends with a colon and you press the return button, it automatically gives you an indent of 4 spaces. And that white space on the left-hand side is meaningful in Python. It's not necessarily meaningful in other programs. For example, if you've ever done anything with SQL or SQL, you can put as much white space as you like on the left, and it makes your code easier to read. But SQL doesn't actually care. You know, it's fine with whatever you do until you hit a semicolon. Python's not that way. The tabbing is very important. Okay, so I create a function called argument1 and argument2, and then I define result, or let's call it my result so that you don't think it's a keyword. My result is equal to argument1 plus argument2. We've got a live band outside. Okay, yeah? Okay, very cool. And then we return my result. So I run that code and I don't get an error message, but I also don't get any response. My function has been saved in short-term memory, but I haven't actually given it any true arguments yet. The next line will use it. Let's use our function, okay? And, sorry, up here, let's define our function, okay? So now we're going to use our function called myfunc, and in parentheses, I'm going to give it two arguments, 2 and 4. And when I run this, I get back 6. And now maybe I want to use it again, and I say myfunc, but this time I'm going to give it 5 and 7. Now I'll get back 12. And reusability for number in here. Let's keep it simple. I was going to do a pair of numbers, but let's keep it simple for right now. For number in 2, 4, 5, 16, 3, and 8, print myfunc parentheses number, and then we're going to add it consistently to 5 each time, okay? Because I gave it 2 arguments, and I don't want to go over the 2 argument thing right now. So then when I run that, it will take each one of those numbers and add it to 5 and spit back these results. And all of a sudden, that's so much more efficient than having to write out the mathematical computation for each one of those numbers one by one across multiple lines. The function gets reused, and when combined with a list, it gets used even more, or reused even more. And that was reusability with one argument, but what if I wanted to reuse with both arguments? Reuse, learn how to type, reuse, with 2 args, it looks something like this. For j, k, n, and here we're going to feed it a series of tuples. 2, 3, 1, 1, and 9 and 2, colon, print myfunc jk. Oh, because it's... And now I can actually automate both of the inputs and not just the one. Questions about that example? And then these lead-ins are kind of similar to that, what I just did above. Now, when working with functions, we really only care about the structure of the function. For example, we can write a function that does the exact same thing with different arguments and a different name. So my previous one was for the purposes of addition, right? It just added those 2 things together. But I can define the same function, and this time I can call it difffunc, and I can give its arguments different names. I can call it n1 and n2, and I can simply say return n1 plus n2. And now difffunc and myfunc will do exactly the same thing. So I can even assert that myfunc 2, 3 is equal to difffunc 2, 3, and I need to print my assert statement. That doesn't like that. Well, the assert runs without a code, which means that it's true, or I can simply get rid of the assert, run it like that, and it comes back as true. So that indicates that the 2 functions are doing exactly the same thing as long as they get similar inputs, even though they were written differently. See, the name of the arguments is really just a label, and the name of the function is really just a label. It's the body of the function that's getting saved and stored, and then just metadata on it is getting tagged in terms of the labels. Okay, take a second and try writing your own function that does some other mathematical computation other than adding. And try it with a list just as I did. I'll leave my examples up here so that you can try yours out with a list and see if it works successfully. I think, yeah, this is the section that you might want to have. Give that a shot. And once you've run it, go ahead and Slack it out. I want to see what these look like. I'll Slack that out here in the general tab. Here. Let me see your functions. So here's my code, and here's what we'll be seeing responses. There is oftentimes a function you can end up being very long, maybe 50 lines long. And so you want to keep your code as readable as possible by breaking it down into smaller parts. So it's a best practice to try and break a function down into as small as possible parts. Now, with something as simple as this, it's not necessary to do that.
Right. But then it's easy to see where you can find.
Exactly. That way, it's just like every single step by step. Future reader will look at my code and say, oh yeah, now we did this, now we did that, now we did the other. But if you're it actually doesn't
Makes sense.
Yeah.
I have a return statement for my function, but it doesn't return anything.
I did not.
So it's working when I say print. It's not working when it's just
Try this. Instead of doing that, how about you just do circle area 4? Does that give a response?
Here?
Yeah, no, in a different code. Sorry, so in escape.
Escape.
Escape. Here, just type circle area. And it does for that one.
But not.
Yeah, the reason it doesn't below is because it is actually calculating each one of those. But you didn't ask it to actually display those results. So it calculates all of them, keeps them in short-term memory, and then stops. So when
Words.
yeah, so yeah, words exactly. So whenever you use a function with a list, you'll want to use a parenthesis inside that list.
Okay. Or get the output.
Or get the output and store it in a different way. Exactly.
Okay, thank you.
Yeah. Okay. You've got a function, go ahead and post it in Slack, and that'll be my cue to move forward. So are folks posting to Slack and I'm just not seeing it? Oh, because it's in exercises, that's why. Sorry, folks, I didn't realize you were all done. I was looking at the wrong channel. I was like, why is nothing showing up? My bad. Sorry. All right, let's take a quick look at these. We've got Regina does multiplication. Jason is doing addition with 3 arguments and division. Max with a very elegant if-else statement. Right? Exponentials. Radius. Modulo. Circle area. So I'm guessing maybe you saw this in one of the future notebooks or had a chance to work on it earlier, or you just do this?
No.
Okay, this is exactly the example that comes up in one of the future notebooks. So
Sorry.
way to get ahead of the game. No, there's no sorry. That's great. Way to get ahead of the game. Okay. Layer also. Okay, fabulous. So it's 7:30. Let's go ahead and take a 10-minute break back at 7:40, okay?